Good morning to all. Today we are discussing about peak detectors. The peak detector circuit as shown in figure. In this circuit, the diode is connected in series to the voltage source and the output terminal is connected parallel to the capacitor. Okay, and here we are giving the input signal is the sinusoidal signal. Okay, this circuit can detect the amplitude of the this signal. Based on the this signal detection, this circuit we are called as peak detector. Okay, so in this circuit we are consider the two conditions. That is, the first condition is if this diode is the ideal diode, and the second one is the this diode is the practical diode. Based on these two conditions, now we are analysis this peak detector circuit. Okay, so here the first condition is the diode is ideal. Okay, we know that if the diode is ideal, here we are mentioned the anode and cathode terminals. In this circuit, this is we are considered the anode terminal and corresponding voltage is anode voltage, and here this is we are considered the cathode terminal, the corresponding voltage is cathode voltage. And we know that first we are applying the open circuit method. It means that this diode is open circuited, and we are determining the anode and cathode voltages. For example, here this diode is open circuited, then the anode voltage equal to input voltage and cathode voltage equal to 0. It means that initially the capacitor is not charged any voltage, therefore the cathode voltage equal to 0. It means that the anode voltage is greater than the cathode voltage, therefore this diode is operated in the forward bias condition, and this can act as a closed switch. Okay, so here we are considered the first condition is the input voltage is greater than 0. It means that here we are giving the positive half cycle of the input signal. At that time, V in means anode voltage is greater than the cathode voltage. Therefore, in the above circuit, the diode is short circuited, and that diode is operated in the forward bias condition, and it can act as a closed switch. Okay, with respect to these conditions, we are redraw the circuit. Here we are applying the positive half cycle Vm, and this diode is short circuited, and here we are connecting the capacitor, and here we are connecting the output terminal. Okay, and now we are determining the output voltage. Okay, so here the capacitor voltage equal to output voltage, and here we are mentioning the capacitor voltage equal to Vc. Okay, you can apply the KVL in this direction, then we can get the corresponding mathematical equation is minus Vm plus Vc equal to 0. Therefore, the capacitor voltage equal to Vm, and we know that the output terminal voltage will be equal to capacitor voltage. Therefore, V out equal to capacitor voltage equal to Vm. Okay, and here we are considered the second condition is input voltage is less than 0. It means that the anode voltage is less than the cathode voltage. We know that in the above circuit, this diode is operated in the reverse bias condition, and this diode is act as an open switch. Okay, so based on these conditions, okay, we are redraw the above circuit. Then here we are apply the negative half cycle Vm, and this diode is open circuited, and here the capacitor is connected, and here we are connecting the output terminal. Okay, and here this capacitor initially charged the voltage equal to Vm. Okay, so during the negative half cycle also, the output of this peak detector circuit V out equal to Vm. Okay, and again we are apply the next positive half cycle. It means that this total complete cycle is completed, and again we are apply the next positive half cycle, that is V input is greater than 0. At that time again we are apply the open circuit method. It means that we need to determining the anode and cathode voltage. Okay, so in this circuit, here Va equal to Vin and here Vin equal to Vm, and already this capacitor initially stored the voltage equal to Vm. It means that the cathode voltage also Vm and anode voltage also Vm. We know that this diode is operated in the forward bias condition based on the anode voltage is greater than the cathode voltage, but here both the voltages are equal. It means that this diode is not operated in the forward bias condition, and this diode is acting as an open circuited. Okay, therefore here we are redraw the above circuit. Okay, so here we can connecting the voltage source, and here the diode is open circuited. Okay, this is the open circuited, and here we are connecting the capacitor, and this capacitor initially store the voltage equal to Vm, and therefore V output equal to Vm. It means that in this during the next positive half cycle also this diode is not operated in the forward bias condition, and here we can get the output voltage equal to Vm. Okay, and again you can apply the next negative half cycle also this diode is not operated in the forward bias condition. It means that this diode is not on, and this corresponding output equal to Vm. Okay, so based on this mathematical expressions, we are draw the input and output waveforms of the peak detector circuit. Okay, these are the input and output waveforms of the peak detector circuit. Okay, so here we are giving the sinusoidal signal is the input, and this signal magnitude is Vm. Okay, and we know that during the positive half cycle of the input signal, okay, up to this half of the cycle the capacitor is charging. Therefore here the capacitor is slowly charging. Okay, after reaching this point the capacitor maintain the same output voltage. It means that here we are consider two conditions, right? The first condition is V input is greater than 0 at the time the V output equal to Vm. It means that the input voltage is greater than 0 at the time the output voltage equal to Vm. Okay, and second condition is V input is less than 0 at the time the diode is off, and we can get the output voltage also Vm. It means that during this duration, up to this duration, the diode is on, the capacitor start to charging. Okay, after reaching this instant, okay, the diode is off, and it will give the constant output voltage equal to Vm. Okay, now here we can conclude the one important point is this circuit can detect the peak amplitude of this signal. Based on this circuit we can call as the peak detector circuit. Okay, and next we are consider the second condition is the diode is the practical diode. Okay, and now we are redraw the above circuit. Okay, here we are consider the this diode is the practical diode, and here we are connecting the output terminal. Okay, and again we are analysis this circuit with respect to this diode is the practical diode, and again here we are giving the input signal is the sinusoidal signal. Okay, and here we are remember one important point is this diode on condition is that is anode voltage minus cathode voltage is greater than the 0.7 volts. Okay, so in this circuit initially this capacitor is not charged any voltage, and we know that this is the cathode terminal corresponding voltage equal to cathode voltage, and this is the anode terminal corresponding voltage equal to anode voltage, and here the cathode voltage equal to 0. Therefore V anode voltage is greater than 0.7 volts. It means that corresponding input signal V input is greater than 0.7 volts, then only this diode is operated in the forward bias condition, and it can act as a closed switch. Okay, so here we are consider the first condition is input voltage is greater than the 0.7 volts. Okay, it means that here we are remember the one important point is this anode terminal is connected to the positive voltage and this cathode terminal is connected to the ground. Therefore definitely during the positive half cycle this diode is operated in the forward bias condition, and it can act as a closed switch. Okay, and we know that this diode is the practical diode in the equivalent circuit point of view. Here this diode is represented as a this constant voltage source, that is 0.7 volts, and here we are connecting the one capacitor, and here we are connecting the output terminal. Okay, and now we want to determining the output voltage. Okay, therefore here we can apply the KVL. Okay, then we can get the corresponding mathematical expression is minus Vm plus 0.7 plus V out equal to 0. Therefore the output voltage or the capacitor voltage equal to Vm minus 0.7 volts. Okay, for example here we are giving some numerical value. For example here we are giving the input signal magnitude equal to, for example, 5 volts. Okay, therefore the output of this detector circuit equal to V output equal to 5 minus 0.7 equal to 4.3 volts. It means that this circuit can detect them up to this 4.3 volts only. Okay, and here we are considered the second condition is the input voltage is less than the 0.7 volts. It means that this is the anode voltage less than the cathode voltage. Therefore this diode is operated in the reverse bias condition, and it can act as an open circuit. Okay, based on this circuit we are redraw this circuit, and here we are mentioned the this diode is open circuited, and this is the capacitor, and here we are connecting the output terminal. Okay, and again we are determining the output voltage. Okay, but in this circuit initially this capacitor stores the voltage equal to how much? Vm minus 0.7 volts, because here the output voltage equal to the capacitor voltage or not. So here the output voltage also equal to Vm minus 0.7 volts. It means that, for example, here you can take the numerical values also. Vm equal to, for example, here we can take them 5 volts. Okay, 5 minus 0.7 equal to 4.3 volts. So based on in this mathematical expressions, we are draw the input and output waveforms of the this practical diode peak detector circuit. Okay, these are the input and output waveforms of the practical diode peak detector circuit. Okay, so in this waveforms, okay, the input is less than 0.7 volts, the diode is not on. It means that it can acting as an open circuited. Okay, if the input voltage is greater than 0.7 volts, then only the diode is on, then the capacitor start to charging. Okay, and the capacitor store the maximum voltage equal to Vm minus 0.7 volts. It means that during the positive half cycle of the input signal, the output voltage equal to Vout equal to Vm minus 0.7 volts. For example, here we can take the Vm equal to 5 volts, then the output voltage equal to 4.3 volts. And during the negative half cycle also, again the output of the peak detector circuit is equal to Vm minus 0.7 volts. Again the output equal to 4.3 volts. Therefore here we are mentioned the output of this practical peak detector circuit during the positive half cycle and the negative half cycle. The output waveform equal to, here we can mention the output is 4.3 volts. So up to here. Okay, and again our doubt is during the next positive half cycle. It means that again we can consider third condition, that is V input is greater than 0.7 volts. At that time the diode is operated in the forward bias condition or the reverse bias condition. It means that during this duration of the signal, okay, the input is 4.3 volts, and the maximum input equal to how much? 5 volts or not. For example, this diode is operated when the anode voltage or the anode or the cathode voltage difference is greater than 0.7 volts. But here the input is 4.3 volts and the maximum amplitude of the input signal is 5 volts, but the difference is not more than 0.7 volts. It means that during this positive half cycle, this diode is not operated in the forward bias condition. It means that again this diode is acting as a open switch. Therefore the output of the this peak detector circuit equal to 4.3 volts. It means that during this duration also the output is 4.3 volts, and even though during the next negative half cycle also the output is 4.3 volts. So in this way we are detect the peak magnitude of the given input signal. Okay, thank you.